In exercise 2.2, sum number 1, what we have to find out is the set A contains 2 elements and the set B contains 3 elements. We have to find out the number of relations from A to B. See, a line is written here, the number of relations from A to B, that is to be 2 raised to the power P into Q, where P is the number of elements in the set where P is the number of elements in the set A and Q is the number of elements in the set B. Here what we find is it is given that NA2 and NB3. Therefore the number of relations from A to B, that is to be 2 to the power of 2 into 3, that is 2 to the power of 6, which is to be 64. Now we need to find out the number of relations from B to A. So the order of the set B is 2 to the power 3 and the order of A is 2, so it is coming 2 to the power 3 into 2, same as before. Now for the set A to A, it is to be 2 to the power of 2 into 2, that is to be 2 to the power 4, that is 16. Now before go into sum number 3, let's see what we understand by the domain, codomain and the range of a relation. Let R be a relation from A to B. Then it is shown in the Venn diagram. Now what we could see is that 2 has mapped to 4, 6 and 10. Then 3 has mapped to 3 is mapped to 4, 6, 9, 10 and 4 is mapped to 4. So let's see what we understand by the domain of a relation. That means only the first components of the ordered pair where AB belongs to R. Right? The range is what? All the second components, that means the B. All the second elements from the order pair is called the range of the relation of R. Now what we understand by the codomain? The entire set B, that is called the codomain. Alright? That means the range is a subset of the codomain set B. Alright. See, in this sum, we have to find out the relation in the roster form where X belongs to A and Y belongs to B such that X is less than Y. That means what? First element should be less than the second element. So from the set A cross A, B, we have to pick up the elements which satisfies the condition X less than Y. So A cross B will contains how many elements? 9 elements. So from those 9 elements, we are not going to write the 9 elements. From these 9 elements, we have to choose the elements which satisfies the condition X less than Y. So definitely 2, 4, 2, 6. Okay. Now check with the 3. 3, 2 not possible. 3, 4. 3, 6. Similarly with 5. 5, 2 not possible. 5, 4 not possible. 5, 6. Alright. That is the roster form of the. In this sum, it is given that A with elements 1, 3, 5, 7, 8 and B is the another set containing 2, 3, 4, 6, 8. We have to show that, or rather we have to find here R in the roster form. R is a relation such that is 1 less than. What does it mean? that the first element, if I take the ordered pair as x and y, the first element x should be 1 less than y. So we have to pick up or choose the ordered pair from A cross B such that x is 1 less than of y. Let's see what are the elements to be. That means what? 1, 2, that can be. Is that 1, 3 possible? No, not possible. So first if I take 1, then it should be 2. Then 1 is less than 2. 1 is less than 1 from 2. Then if I take 3, now we have to look for the pair for 3. It may or may not be possible for all elements of A. Then 3, 4. Similarly 4, not 4, 5 is less than 6. 7 is 1 less than 8, and but 8 is 1 less than 9, but the 9 is not there, so we cannot take anything with the 8. So this is the set of 8. Now in next sum it's given that A and B are the sets. Relation R is given that x and y belongs to A cross B such that x is a factor of y. That means what? Y is divisible by x. We have done this kind of sums before. Okay, so x should be a factor of y. So let's check. We have to pick up the ordered pairs which satisfies the condition x is a factor of y. So then we can take 2, 4, 2, 6, 9 not possible. Then 2, 10, 3, 4 not possible, 3, 6, 3, 9, okay fine, and then 3, 10 not possible. Then 4, 4 is a factor of itself. Then no more possibilities with 4. That is it. In the first sum, here it is given A is the set containing 5 elements 2, 3, 4, 5, 6, and R is a relation on A cross A. Here one thing to be noted that there is no second set B. That means we have to take the cross product of A with itself, but from there we have to choose the subset or the relation R or the elements of the relation R such that y is equal to x plus 1. That means what? The second component should be 1 greater than our first component. It is very similar to the previous sum only. Now we have to find out what are the ordered pair which following the condition y is equal to x plus 1. So we have to write the R in the roster form. Let's say 2. What are the possibilities with the first element 2? 2, 3. Okay. Then 3, 4. So we have to take A to A. Then for 3 I have to check whether the pair exists for 3 or not. Then 2 is the pair of 2 is 3, but 2, 4, 2, 5 all are not possible. Similarly 3 with 4, that pair is possible. Then 4, 5, 5, 6. For 6 we do not have any element. Now in this sum, write the following relations in the roster form where the relation is defined by R. First line is R is equal to x comma x cube, where x is a prime number less than 10. Like we have to first choose the prime numbers in the first position, or the first element of the ordered pair should be what? Prime numbers, but that prime number under the condition should be what? Less than of 10. That means we can take the prime numbers which are less than of 10. Along with that, the second element should be the cube of the first element. That is how we have to choose the order pair here. In the second sum, it is given that choose all ordered pair such that the first one is x minus 2, second one is the square of x, but again x is a prime number less than of 10. Okay, now what are the elements to be? So what are the prime numbers less than of 10? As we have seen in the previous part, that 2, 3, 5, 7. So the first element should, so that is 0 comma 4. Second element is 3 minus 1, 3 minus 2, that is 1 comma 3 square, that is 9. Similarly, we need to find out the other elements. In this sum, it is given that A is the set 1, 2, 3, 4 and B is the set X, Y, Z, and a relation R is defined by, is given in the roster form 1 comma X, 1 comma Z, 3 comma X and 4 comma Y. I have to find the domain and the range of R. Domain means is already described before. The domain means all the first elements of the given set. So what we find, repeated values will not be accepted. We are going to take then 1 comma 3 comma 4. Now the domain of R, as I said, it is to be 3 and 4. Then the range of R will be X, Y, Z, okay, or you may write X, Z, Y. Second pi, represent R by an arrow diagram. So that means what? Let's say R A contains 1, 2, 3. X is related, 1 is related to X, 1 is related to Z also, 3 is related to X, 4 is related to Y. Let us solve another problem on domain and range. So we have to find out the domain, which is to be 1, 2, 3, 4, 5 including 0, and the range is the second element, that is x plus 5. That means 0 plus 5, 5. For 1 it is to be 6. For 2 plus 2 plus 2 plus 2 with each and every element. Now here is given that a relation is given here, that with the arrow diagram it is given that A contains the elements 5, 6, 7 and B contains the element 3, 4, 5. So we have to write the relation in the roster form. That means which element is correspond to which element. Alright, so let's see that. Then 5 is related to 3, 6 is related to 4 and 7 is related to 5. Now we have to write it in the set builder form. So we have to find a relation among each and every ordered pair. So we have to describe the relation holds by the ordered pair. So if you check that each element, the first component is 2 greater than the second component, but all of them are the natural numbers, and y is x minus of 2. Here in this sum is given that determine the domain and the range of the following relations. The first one is given that all ordered pair xy where x and y both are natural numbers and x plus y is 10. So we have to find out the set of natural numbers whose summation is to be 10. First we have to find out those in the set builder from there we'll pick up the first elements of the order pair that will be in the set of domain, and in the range set all the second elements of the y to be there. So first thing to do is we have to find the order pair which belongs to the given relation. So let's check 1928 3746 and the remaining element. Okay, so the domain of this to be what? 1 2 3 4 5 6 7 8 9. Then the range is what? Pick up the second elements. Again 9 8 7 6 5 8 4 3 2 1. Practically here the domain becomes the range is equal. Second one is what? X is a natural number such that x is a less than 5, but y is a fixed element, that is 3. So check the ordered pair. Always it is to be 3 in the second position, and the first place should be filled up by natural numbers which are less than of 1, less than of 5. Now from there find the domain, and the domain is 1 2 3 4 and the range is 3 only. Now here R is given all ordered pair A and B where both A and B are natural numbers and satisfying the condition A plus 3B is equal to 12. Then we have to list the elements of R, the domain of R, and find the range of R also. First we have to find out the value of B in terms of A, as we have done in linear equations, solving of linear equations in class 9. Now B is expressed in terms of A, that is 12 minus A by 3. Now if I put any value of A more than 12, then it's become a negative, which is not possible because the B is a natural number. Therefore A should take up all the values which are less than of 12, that means 1 to 11. Alright, now we have to check for what values of A we get the B is natural number. Similarly we have to find out the order pair following this condition also. So if A is 3, B is 3, calculate, put A as 6, we are getting B as 2, and A is 9, then B is 1. Then the order pair are to be 3 3 6 comma 2 and 9 comma 1. Now from there we have to find the domain of the set. That means domain is what? Only the first components, as we know, that is 3 6 and 1 3 6 and 9, sorry, and the range is what? 3 to 1 1. Now in this sum is given that R is a relation x and y ordered pair such that y is equal to x plus 12 by x. Now one thing to be noted here, that x and y both should be natural numbers. Now y would be a natural number provided that 12 by x, that is a natural number. So in what are the cases that y will be a natural number, or rather for what are the values of x's for which the y should be a natural number. Now y is x, that part is not a problem because x is a natural number, and as we know the sum of two natural numbers is a natural number. So the second part 12 by x has to be a natural number. So under what condition that 12 by x will be a natural number? So we have to consider only the values of x which are factors of 12. Alright, that means we have to consider the x values only when x is a factor of 12. So what are they? It would be then 1 2 3 4 6 and 12 itself. So we have to find the corresponding values of y where x is equal to 1, 2, 3, 4, 6 and 12. For these values of x's, we have to find the values of y. If you put x as 1, what do you get? Y is equal to 1 plus, that is coming to, see first what we have to write. We have to represent in that form that y will be a natural number provided 12 by x belongs to n. That is possible only when x should be a factor of 12. So x is equal to 1, 2, 3, 4, 6, 12. This is how to be represented. So the relation would be what? For x equal to 1, it is to be 1 plus 12. So it's coming to 13. So for x is 2, it will be 2 plus 6, that is 8. For 3, 12 by 3, that is equal to 4 plus 3. Similarly for 4 it is 4, 7, and for 6 it will be 2 plus 2, 2 plus 6, that is 8. And for 12 it is 12, 13. Now to find out the domain of R. That means what? The x values only. The ones which are written for x's, they are the elements belongs to the domain. So 1, 2, 3, 4, 6 and 12. And the range will be what? Just pick up the second elements of each ordered pair. Check. Here we have to write down the domain and the range of the relation x and y such that x is equal to 3y. That means what? Whatever be the value of y, that's the second element of the order pair, x value will be 3 times of it. Alright, but at the same time it is also provided that x and y should be less than of 10. That means both of them to be natural numbers, to be less than 10, and must be following the condition x equal to 3y. So what are the numbers could be? So if I put y as 1, then x is coming to what? 3. Alright, because 1 into 3 is 3. Second one, we have to put the values of x's and to check that x should not exceed 10, it should be less than of 10. Now if I put y as 2, then x is coming to 3 into 6, so it is 6 comma 2, and y is 3, then x is 3 into 3, that is 9. Now to find out domain and the range of R. So domain means what? The 3, 6, 9, and the range is 1, 2 and 3. In this sum, it is given that R is a relation containing x and y such that the y is equal to 2 times of x minus 4. And it is also provided that two elements a comma minus 2 and b comma 4 square belongs to the set R. We have to find the values of a and b. Alright, since the first element a comma minus 2 belongs to R, that will satisfy the condition of being in the relation. That means what? It should be y, that is minus 2, is equal to 2 times of x, that is 2 times of a minus 4. So check the relation that a comma minus 2 satisfies the relation, as well as b comma 4 comma b square also satisfies the relation 2x y is equal to 2x minus 4. So as we have described, from the first element minus 2 is equal to 2a minus 4, and from the second one b square is equal to 2 into 4 minus 4. So from these two we have to find the values of a and b. So a is coming to is equal to 1 and b square is coming to 8 minus 4, that is square is equal to 4, so this is equal to plus minus 2.